Hello, welcome to CrossShade from Maya. Our team members are Eric and Nop. Before we begin, here's an image showing an example output from our tool appearing directly in Maya. Our tool is based primarily on this paper, CrossShade, Shading Concept Sketches Using Cross-Section Curves. The motivation behind the creation of this tool is that designers rely on cross-section drawings to quickly construct sketches. Sketches are important for conveying ideas in any production studio. Shading an image adds much needed depth to a sketch, but it can be a long and tedious process. Therefore, our goal is to automate the shading process of cross-section drawings. For an artist using our tool, the input is an image of a sketch. The artist then authors cross-section curves in Maya using the NURBS Curves tool. Our tool will output a mesh in 2D with 3D normals. This mesh can then be used for shading with various lighting setups. Our technical approach was based again primarily on the paper CrossShade by Shaw, Bousseau, Sheffer, and Singh from SIGGRAPH 2012. We also referenced the paper Discrete Coons Patches by Farron and Hansfield from 1999 for part of the algorithm. In our implementation, we used Maya for curve authoring and Mel for the UI. Python was used for curve interpretation, and a third-party library called SciPy was used for the optimization part of the algorithm. Python and Mel were used conjunctively for mesh construction. Here's an overview of the steps of the CrossShade algorithm. We take in as input curves from the user defining the 3D contour of a 2D sketch. Then we interpret the curve network and extract crosshairs, which are intersections of curves. We then solve a minimization problem to calculate the normals at each crosshair. These normals are interpolated along the curves and then interpolated along Coons patches in the regions enclosed by the curves. Finally, we output a 2D mesh with 3D normals that can be assigned materials, lighted, and rendered. We now present images for each step of the algorithm. First, we see a sample network of curves that a user would define. Here we see intersections interpreted from the curve network. After solving a constrained minimization problem, we have the 3D normals for each crosshair. These normals are propagated along the curves using interpolation. The normals are further interpolated along the interior regions of the curves using a method called Discrete Coons Patch Interpolation. Here's a visualization of the 3D normals at each vertex of the constructed mesh. After adding a light and turning on smooth shading, we can see the 3D appearance of the shape even though the mesh itself is 2D. The mesh can then be rendered with any materials and lighting conditions just like any other mesh. Now we will run through an example usage of our tool from start to finish. We've loaded up a sketch and are now adding curves defining the cross sections of the image. The curve authoring process takes a moment depending on the complexity of the sketch and the accuracy with which the user places the curves. So we'll talk about a couple of our design decisions. One is a minimalistic and intuitive UI. CrossShade is supposed to be a simple addition to the sketching pipeline and thus requires a little more than running the core algorithm. Another is that after a user finishes authoring curves, he selects all the curves he wants to use as input for CrossShade. This allows the user to create multiple different shaded meshes in one scene, as we will see in a moment. Now with the curves selected, click Run CrossShade. The algorithm must solve an optimization problem through iteration and thus takes a few seconds to complete. We now have a 2D mesh with 3D normals. We can see the 3D shading by adding a light and moving it around. The toothpaste bottle appears three-dimensional. Each region enclosed by curves is created as a separate mesh. Since it is a set of meshes with altered vertex normals, we can assign shaders and add multiple lights as we will see in a very simple example. We also see that this allows users to change lighting or material conditions to alter shading without having to resketch and reshade the image manually, thus saving lots of time. Also, viewing it from perspective view shows that it is indeed just a 2D mesh, but exemplifies 3D shading. We can then render it as a scene, just like any other mesh. And that's all. Thank you.